I want to share with you some of the key learnings that I had in doing my research for my doctoral program. So way back when I started, just to give you a little bit of an introduction about me, way back when I started my program, people said to me, make sure when you pick a topic that you really care about, because at the end of the process, you have to have that because you won't make it through unless you do. So at the time that I started my journey, I was actually a math consultant in my board. And this is a topic that used to come up year after year after year, as I'm sure it does for those of you that are in the room at a system level. Every year when the EQAO results came out, we would have sort of the same old story, I guess. We'd look at the results, and we'd always find there seemed to be this huge chasm between how our students in applied courses were doing and how students in the academic courses were doing. So my background particularly is as an elementary teacher. I'm not a secondary teacher, but I taught in the intermediate grades. So my kids were going off to high school, and I always sort of wondered, what's happening with some of those students who are landing in applied classrooms? Why aren't they being successful? And the problem is, I guess if we want to look at it that way, is it's kind of an important problem, I guess, that we think about. You don't need me to tell you that this has been a problem for a while. So at the very beginning of my journey, and remember it took me about 7 years from start to finish, I really started every year to kind of look what's going on with grade 9 applied. For a while there we talked about it must be the curriculum's fault. It must be that. So even we had a curriculum change, and you can see on the slide the light blue band at 2005-2006. You can see that's where the curriculum changed. So you can see we have this huge gap. That's my concern. This gap between how students in applied classrooms are doing and how students in applied classrooms are doing. We had this huge gap that is very stubborn. So if the academic results went up, the applied maybe would go up, but they never really caught up. We had a curriculum change, things seemed to get better for a bit, and then off we were again with this big, huge gap. So I want to share with you a few reasons why I think we really need to care about this from the Ontario context. So again, as I was doing my research and as I was studying these things, I would uncover some of the lessons that we've learned from Ontario. So here's one of the lessons that I think is really important. Actually, the significance of actually achieving standards. So by standard, you know what that means. It means students are achieving at level 3 and beyond. So level 3 is equivalent to a B, really, for all intents and purposes. And we know that if students achieve at provincial standard in grade 3 or grade 6 or grade 9, parents can be confident that their child will do well in the next grade or in the next course. That's a fact. We have Ontario research that tells us that. So that's the first reason that we should care. We should care about getting kids to standard because when they get to standard, they're better poised for the next milestone, the next grade. If they get to the next grade, the next milestone not poised, it's going to be tough. So that's the first reason that we should care. Second reason that we should care is the impact of actually failing. And again, we have oodles and oodles of Ontario research that tells us if students don't actually get their 16 credits by age 16, it's actually going to put them in a deficit mode. So that's really important. So if we look at the statistics, we know that 41.3% of students who started grade 9 applied math did not actually earn those credits by the end of grade 10. And oftentimes it was because of math. Yet, on the flip side, students in academic classrooms, only 14.4% of them didn't get their 16 credits. So that's very significant. One little course can make a huge difference for students. So that's another reason that we should care. The next thing we need to think about is consequences for future study. And I'm just going to remind you that the applied course is part of a suite of courses for a pathway. And the pathway, one of the pathways for students is actually to go on to college. Some students will go off to work, but many of them will go off to college. Again, we have all kinds of research from Ontario that tells us that if students don't go off to college well prepared from high school, they're going to hit brick walls. So approximately 40,000 students are enrolled in college mathematics. 25.8% of them actually have to take remedial math courses when they get there because they're not prepared. And this is actually a number that's going up. And the college folks will tell us that those are students who are taking the applied course. In fact, 50% of those students who had taken grade 9 and 10 mathematics courses were actually at risk in college first semester when they get there. The other statistic that we know is that students coming into college with a D in applied math either fail or drop out of college in their first year. Lots of them actually go home at Christmas time and they don't come back because the math gets in the way. So we really have to think about, this is a course that's preparing students for a pathway, which is college. And a lot of times we console ourselves and we say, well, you know what? Students in applied classrooms, they don't learn that way. They don't do paper and pencil tests or tests and that sort of thing. EQAO is just silly because that's not how they learn. I just want to remind you, when they go off to college, I'm pretty sure they're going to have to take a test. And actually, when they want to get credentials and apprenticeships and all of those sorts of things, I'm pretty sure they're going to have to take a test. So we have to prepare them for that. Otherwise, they're going to just be heading off into a storm. We know that. We have research that tells us.